Have you ever felt it? That quiet hum beneath the surface of the world, that sense of a vast, unseen ocean you are swimming in. It's a feeling you may know, especially if you find comfort not in the clamour of a crowd, but in the silent spaces between thoughts. For the introspective mind, the universe isn't just a collection of stars and planets, it's a profound cosmic riddle. And right now, the biggest piece of that riddle, the one that's been baffling the brightest minds for over 2 decades, is something called dark energy. Dark energy is the invisible force that's not only shaping our cosmos, but also mirroring the very mysteries within you. What if the answers you're looking for in the silent, swirling expanse of space are also the ones that explain your own silent, swirling thoughts? Part 1. The Cosmic Detective Story. Think of a detective story. For centuries, astronomers were the lead investigators mapping the crime scene of the universe. They saw galaxies flying apart, just like shattered pieces from a cosmic explosion. The leading theory, the Big Bang, explained this perfectly. It said the universe began in a fiery instant and has been expanding ever since. For a long time, everyone assumed gravity, the universe's great cosmic glue, would slow this expansion down. It was like throwing a ball into the air. You expect it to slow down and eventually come back to Earth. To feel the shock of dark energy, you first need to understand what everyone thought was true. For most of history, we thought the universe was static, eternal, and unchanging. Even after Einstein gave us his theory of relativity, which could describe a universe that was expanding or contracting, he clung to the idea of a steady state. He even added a number to his equations, a fudge factor he called the cosmological constant, to force the universe to stand still. He called it his biggest blunder, but you'll see why he was actually onto something. Back in 1929, Edwin Hubble discovered that galaxies are moving away from us. That was weird enough, but then, in 1998, a strange and shocking discovery rocked the scientific world. 2 independent teams of astronomers, one led by Saul Perlmutter, Supernova Cosmology Project, and the other by Brian Schmidt and Adam Rees, High-Z Supernova Search Team, were studying distant supernovae. These are massive exploding stars that act like cosmic lighthouses, their brightness helping us measure distances across the universe. They were expecting to see the expansion of the universe slowing down. Instead, they found something completely opposite. The expansion wasn't slowing down at all. The supernovae were about 25% fainter than expected, meaning they were farther away than predicted. This could only be explained by an acceleration of the expansion rate. It was if some invisible anti-gravity force was pushing them apart. This discovery was so groundbreaking that it earned them the Nobel Prize in Physics in 2011. It was a complete game changer. It was as if your ball in the air, instead of slowing down, suddenly got a rocket booster and shot off into space. The rate of the universe's expansion is given by the Hubble constant, the H0. The Planck satellite's measurement of the cosmic microwave background means a galaxy 1 megaparsec, about 3.26 million light-years away, is receding from us at 67.4 kilometers per second. This mysterious repulsive force, this cosmic rocket fuel, was given the name dark energy. Why dark? Because you can't see it, you can't feel it, and you can't directly measure it. It doesn't interact with light or matter in any known way. You only know it's there because of its effects, and its effects are staggering. The current Lambda CDM model, which is the standard model of Big Bang cosmology, suggests that dark energy makes up about 68% of the entire universe's mass and energy. Compare that to dark matter, the other cosmic mystery, that makes up about 27%. And then there's the so-called normal matter, the stuff you're made of, and the stars, the planets, the galaxies, which is only a measly 5%. That means everything you can see, everything you've ever known, is just a tiny fraction of the cosmic picture. Dark energy is the quiet, unseen force pulling the strings of the universe. Part 2. The Search for Understanding. Scientists have proposed several theories to explain dark energy. The simplest is that empty space itself has energy, what physicists call vacuum energy or zero-point energy. Even in the emptiest regions of space, quantum mechanics tells us that virtual particles constantly pop in and out of existence. This quantum foam might be the source of dark energy, but there's a problem. When physicists calculate how much vacuum energy should exist, their answer is wrong by a factor of 10 to the power of 120. That's not just wrong, it's the most wrong prediction in the history of science. The theoretical value is so enormous that it would tear apart every atom in the universe instantly. The estimated density of dark energy is extremely low, about 7 times 1030 grams per cubic centimetre, or 6 times 1010 joules per cubic metre. Despite this, its uniform distribution across space allows it to dominate the universe's energy budget. Another possibility is that dark energy isn't constant but changes over time. This theory, called quintessence, suggests that dark energy is a dynamic field that fills space and drives expansion. Unlike vacuum energy, quintessence could vary in strength and even change sign, positive or negative, potentially causing the universe to contract instead of expand. Projects like the Dark Energy Spectroscopic Instrument, or DESI, a 5-year survey aimed at creating the largest 3D map of the universe, are mapping millions of galaxies over billions of years to see if the strength of dark energy has changed over time, which would support a quintessence model over a constant cosmological constant. The DESI survey has already measured the universe's expansion history with high precision and has observed a new set of up to 5,000 galaxies every 20 minutes. Some scientists propose even more radical ideas. Maybe our understanding of gravity is incomplete, and what we interpret as dark energy is actually a modification of Einstein's theory of general relativity on cosmic scales. Or perhaps we live in a higher dimensional universe, and dark energy is the result of interactions with dimensions we can't perceive. Some astrophysicists believe dark energy is a clue that our universe is part of a multiverse, a vast sea of universes, each with different rules. Maybe we live in one where dark energy is just right to allow stars, planets, and life. That's the anthropic principle, which is the idea that the universe looks the way it does because we're here to see it. So, why does dark energy matter? It's not just about understanding some obscure phenomenon, it's about grasping the underlying structure of the universe. Dark energy could hold the key to unlocking new physics, new theories, and a deeper understanding of the cosmos. It's like finding the Rosetta Stone of the universe, a key that could decipher the secrets of existence. Part 3. The future of dark energy. The Nancy Grace Roman Space Telescope is being built to tackle some of the biggest questions in modern cosmology, with a major focus on dark energy. While the Hubble Space Telescope helped discover dark energy, Roman is designed to follow up on those findings with a new level of precision and scale. Here's how Roman plans to do this. Wide field of view. The telescope has a primary mirror the same size as Hubble's, but with a field of view at least 100 times larger. This allows it to capture vast swaths of the sky in a single image. For studying dark energy, this is crucial, because it allows scientists to map hundreds of millions of galaxies and find tens of thousands of Type Ia supernovae over its 5-year mission. This massive dataset will provide much more statistical power than previous surveys. Supernovae as standard candles. Just as the original teams did in the late 1990s, Roman will use Type Ia supernovae as standard candles to measure cosmic distances. By finding these supernovae at greater distances than ever before and in much larger numbers, astronomers can more accurately trace the universe's expansion history over time. This will help determine if dark energy's effect has changed throughout cosmic history. Weak gravitational lensing. Roman will also study dark energy by observing a phenomenon called weak gravitational lensing. This is the subtle distortion of the light from distant galaxies as it passes through the gravity of massive objects like galaxy clusters and dark matter. By mapping these distortions, scientists can create a 3D map of the distribution of both visible and dark matter throughout the universe. Dark energy's influence on cosmic expansion affects how this structure evolves, so these maps can be used to test different dark energy models. High-latitude time domain survey. A key part of Roman's mission is its high-latitude time domain survey, which will repeatedly observe wide, deep regions of the sky to look for transient events, including supernovae. This dedicated survey is specifically designed to collect the data needed to understand how the expansion of the universe has evolved. Ultimately, Roman's role is to move the field beyond the initial discovery of dark energy and into a new phase of precision cosmology. It's not just about confirming that dark energy exists, but about determining its fundamental nature. Is it a constant cosmological constant or a dynamic, time-varying field like quintessence? Roman's data will be essential for helping scientists choose between these competing theories and potentially uncovering new physics. Part 4. A new chapter for humanity. This is a key moment in our cosmic story. The existence of dark energy means that our universe is not just a place of things, but a place of forces. It's not a static picture, but a dynamic, ever-changing canvas. We once thought we knew the end of the story, such as a big crunch, where the universe collapses back on itself, or a big freeze, where the universe slowly expands and cools. If dark energy continues to accelerate its expansion indefinitely, the universe may face a heat death, a state of maximum entropy where no usable energy remains. But dark energy has added a new mind-bending chapter. With this relentless acceleration, the ultimate fate of our universe might be a big rip, where the expansion becomes so violent that it eventually tears apart everything, including galaxies, stars, planets, and even atoms themselves. That's a possibility, but it's a long, long way off. The Euclid mission, launched by the European Space Agency, is currently mapping billions of galaxies to better understand dark energy's role in cosmic expansion. Early results suggest dark energy may not be constant, challenging the standard model of cosmology. The quest to understand dark energy is a call to those with a knack for deep thinking. It's an invitation to confront the unknown, to sit with uncertainty, and to find beauty in the things you can't yet see. It's a humbling reminder that the cosmos is far stranger and more magnificent than we ever imagined. The very nature of reality is a riddle wrapped in a mystery, and dark energy is the ultimate testament to that. Part 5. The Philosopher's Way In. Here's where the problem gets really interesting and where it connects with that quiet, contemplative part of you. You're trying to understand a force that is invisible, silent, and works on scales beyond our comprehension. This is a challenge for everyone, but for the quiet mind, the one that finds peace in observation and solitude, it resonates on another level. Here's what some of the major philosophers have to say about dark energy. Philosophers like Immanuel Kant argue that our understanding of reality is shaped and limited by the structures of human cognition. We perceive space and time because our minds are wired to do so, not necessarily because they exist out there in the way we think. Dark energy, which defies direct observation and yet dominates the cosmos, echoes Kant's idea that reality may include dimensions or forces beyond our sensory grasp. David Bohm has proposed that reality is layered and what we see is just the surface. Beneath it lies a deeper, interconnected order. Dark energy fits this view. It's not part of the visible world, but it's woven into the fabric of space itself. The discovery of dark energy is a monumental case study in epistemology, which is the philosophy of knowledge. Philosophers like Alison Fernandez and others working in the philosophy of cosmology point to it as a supreme example of how science humbles us. The philosopher of physics, James Owen Weatherall, highlights that dark energy forces us to radically redefine our metaphysical categories. Nothing might not be nothing. It might be a something with properties, like energy density and negative pressure, that actively shapes the cosmos. Philosophers Nick Bostrom dissects this principle, questioning whether it is a genuine explanation. Does it explain why the constants of nature, like the strength of dark energy, are set to life-permitting values? Or does it just point out our own observational bias? Dark energy sits at the heart of this debate, forcing us to confront whether the universe is fine-tuned for life and what that could possibly mean. Now, an introspective person like yourself isn't afraid of a problem without a clear solution, and here's a thought. What if the most powerful forces in the universe, the ones truly shaping its destiny, are not the loud and flashy explosions, but the silent and unseen energies? The expansion of the universe isn't a noisy, chaotic event. It's an elegant, almost meditative acceleration, guided by a force you can only infer. Part 6. Embracing the mystery. So, why does dark energy matter? It matters because it's not just some abstract scientific puzzle. It's a mirror to your own existence. It tells you that what is invisible can be incredibly powerful. It tells you that the universe is full of mysteries you have yet to uncover, and that your understanding is a work in progress. For an introspective person such as yourself, this can be a comforting thought. The universe is not shouting its secrets from the rooftops, it's whispering them to those who are patient enough to listen. And perhaps the greatest part of this story is not finding the answer in our lifetime, but in the journey itself. A journey that teaches you to embrace the vast and beautiful unknown, both in the cosmos and within yourself.